Hello, welcome back once again. Today we have this interesting equation, a transcendental equation for that matter. And here we're going to solve for the real value of x that will satisfy this equation. So let's get started. From the left hand side here we have 2 to the power of x plus x. This is equal to 20, right? Now this x here is positive, so let us take it to the right hand side and that will become negative. From that right hand side we're going to have 20 minus x. This will be equal to, from the left hand side we're left with only 2 to the power of x, right? Now in our next step, let us divide both sides by 2 to the power of x. We get here 20 minus x divided by 2 to the power of x. This will be equal to 2 to the power of x divided by 2 to the power of x. Okay, so now let us record this. We know 1 over a to the power of m is equal to a raised to the power of negative m. So we're going to use that here. So we have here 20 minus x. This will be times 2 to the power of negative x. So this will be equal to, here this divides to 1, right? Okay, now we're trying to make the power of 2 equal with the expression in the bracket. So we need to multiply both sides of this equation by 2 to the power of 10, right? Because we know that a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. When you multiply 2 to the power of 10 to both sides, remember that this base here is 2, the base here is 2, so this will become negative x plus 10, which is the same as 10 minus x. Oh, sorry, I mean 2 to the power of 20. I'm so sorry for that. Okay, so the base here is 2 and the base here is 2, so you know, using this property here, we're going to add the powers, so this will become negative x plus 20, which is same as 20 minus x, and that power will become the expression in the bracket here. Okay, so here we have 20 minus x times 2 to the power of negative x multiplied by 2 to the power of 20. So this will be equal to 1 times 2 to the power of 20 will give us 2 to the power of 20. Now with this property here, we add these powers. So we get here 20 minus x times 2 to the power of 20 minus x, right? Okay, so this will be equal to 2 to the power of 20. Again, let us rewrite this 2 to the power of 20 minus x using this property. A to the power of b is equal to e to the power of b times the ln of a. Okay, so using this here, so this will become e to the power of 20 minus x times the ln of 2 multiplied by 20 minus x. So this will be equal to 2 to the power of 20. Okay, now for us to obtain equal power and coefficient here, we need to multiply both sides by ln of 2. So here we get e to the power of 20 minus x times the ln of 2 multiplied by bracket 20 minus x times the ln of 2. So this will be equal to 20 to the power of 20 times the ln of 2. Now we're going to make use of the Lambda-Dobby function, but before that, let us concentrate more on the right hand side. There's a nice algebraic manipulations we're going to do here. And let's see what we're going to do here. We're going to obtain a number multiplying the natural log of 2, which should be equal with the power of 2. So let's see how we're going to do that. We know that 2 to the power of 20 is equal to 2 to the power of 19 plus 1, which is same as 2 to the power of 19 times 2 to the power of 1, which is 2. So this will be equal to 2 to the power of 18 times 2 times 2, which is 4. You know that 4 is 2 squared. So 2 to the power of 18 times 2 squared will give us 2 to the power of 18 plus 2, which will give us 2 to the power of 20, which we started from, right? So if we continue, we get 2 to the power of 17 times 8. I think so, yeah. We get 2 to the power of 16 times 16. Amazing. So this, we're going to put it here in place of 2 to the power of 20. So from the left hand side already, we have e to the power of 20 minus x times the ln of 2 times here 20 minus x times the ln of 2. So this will be equal to, here we write as 2 to the power of 16 times 16 times the ln of 2. There's a very nice reason for this. Okay, so now remember this property here. We're going to use it here. So this will become here, this will be equal to here, this will be e to the power of 16 times the ln of 2. Then multiply by 16 times the ln of 2. From the left hand side, we still have e to the power of 20 minus x times the ln of 2. Multiply by 20 minus x times the ln of 2. Now we're going to make use of the Lambert-Dobby function on both sides. But we need to explain or talk about this Lambert-Dobby function. Okay, here is the property. The Lambert of f times e to the power of f is equal to f. You can see that this f here as the power of e is equal with this f here. So if you look at this here, the power of e here is equal with this expression here. And from the left hand side, the power of e here is equal with this expression. So therefore, the Lambert-Dobby function at the left hand side simplifies to 20 minus x times the ln of 2. And from the right hand side simplifies to 16 times the ln of 2. From both sides, we can get away the ln of 2 or divide both sides by the ln of 2. Then we are left with 20 minus x is equal to 16. Of course, we get x is equal to 20 minus 16, which is equal to 4. What a nice manipulation. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe, like, comment, and share. So finally, we get our result. X is equal to 4 is our solution.